So let's have the solution to example 12. A billboard 3 meters high by 4 meters wide is supported by two identical frames ABC, one on each end as shown in the figure. The total weight of the billboard is 36 kilonewtons. Wind pressure Q is 1.8 kilopascals and the wind pressure coefficient is 1.0. So determine the horizontal component of the reaction at A in kilonewtons. And what is the axial stress in the strut DC in megapascals whose cross-sectional dimensions are 5 mm by 75 mm? And number 3, if the strut AB were replaced by a 20 millimeter diameter cable, determine the normal stress in megapascals in the cable. So to solve for these normal stresses, you simply compute for the member forces or bar forces. So this is the figure in side view, but it is stated here that it is supported by two identical frames ABC. So it is not only ABC, there's another one, or else it will swing. So the picture, to give you an idea, it should look like this in pictorial view. So this is the frame ABC, this is one, and we have another one, this table. So therefore, the load for the wind force at B, the weight should be divided by 2 and transmit it to just one frame for the analysis. So the weight of the billboard, which is 36, I will just show here 18. So we have here the wind load, which is equal to wind pressure coefficient 1 times the pressure 1.8 kilopascals times the area of the billboard, which is 3 by 4, so 12. This is 18, half of 36. So we have, let's assume AB to be in tension and BC to be in compression. So at joint B, we have the wind load, wind pressure coefficient, which is 1, and times the pressure, which is 1.8 kilopascals or kilonewton per square meter. So we should multiply that by the area, which is 3 by 4, and divide it by 2 because we want to transmit the load in just one frame. So wind load is 10.8 kilonewtons. Then we have to apply equations of statics, summation versus x at summation versus y equals 0. First, summation versus x equals 0. So FAB is leftward, BC is rightward. So the horizontal component of FAB is negative FAB cosine 30 plus FBC cosine of 30 equals wind load, which is 10.8. So call that equation 1. Summation versus y equals 0. So we have FAB sine 30 plus FBC sine 30 equals 80. So solving these two equations simultaneously by substitution or by elimination, not using your calculator because that's not allowed anymore. And it's up to you. If you use your calculator, you're not training yourselves with a calculator that is acceptable in the board exam or in the future. You just use that for solving or checking your solutions. Okay, but begin by training yourselves with the low-tech calculator, because if in the summative exam, I will not allow you to use your high-tech calculator. So solving these two equations simultaneously, we have FEB equals 11.765 kilonewtons and FBC is 24.24 kilonewtons. All are positive, so that means our assumed sense of these forces is correct. So FAB is tension, FBC is compression. Now, let's compute the horizontal component of the action at A. So if this is A, the force is away because it is tension, therefore the horizontal reaction is also away, going to the left. And that HA is simply the horizontal component of FAB. So it is 11.765 cosine of 30. So horizontal component at A is 11.765 cosine of 30 degrees. So HA is equal to 10.19 kilonewtons. Let's proceed to the second question. The normal stress in stat BC, if BC is rectangular in cross section 5 mm by 75 mm. So it is just force over area. So 24,240 newtons divided by quantity 5 mm times 75 mm, the result will be megapascals. So axial stress in stat BC is 24,000 FBC over area BC. So 24,000 240 divided by 5 times 75. So the answer is 64.64 megapascals. And finally, the normal stress in cable AB, if it is replaced by a 20 mm diameter cable, so it is 11,765 divided by pi times 10 squared. The area is pi r squared. So stress in AB, FAB over area AB, so it is equal to 11,765 newtons divided by pi 10 squared. So the stress is equal to 37.45 megapascals tension. So that's it.